Hey guys, Mr. B here again, bringing another math video. This one is on implicit differentiation. So what I'm going to do for this video is I'm going to take the derivative of both sides. So what I mean by implicit differentiation, of course, is that this is not an explicit function. It's not y equals. So because of that, we have to use a special derivative technique called implicit differentiation. So basically what I end up doing is taking the derivative of this thing with respect to x, and I do it on both sides. So d over dx, x plus y squared, and then d over dx of x times y. So I got the derivative of both sides. So I still have to obey any general derivative rules, like this side's product rule, and this side over here, that's chain rule. So I have the derivative of this guy, so it would be 2u. So I'm using chain rule right now. So the derivative of u squared is 2u, so 2x plus y times, and I'm just going to put my u prime right here, so I still have that to do. And then this guy over here, that is just product rule, so derivative of x is 1, I'm not going to write it, times y, plus the derivative of y is y prime, so x y prime. Anytime you take the derivative of something with respect to y, you need to think about the y prime aspect of it. So what I mean by that, so if you had something like y squared, the derivative of that will be 2y times y prime. Basically this is chain rule, right? So the derivative of u is 2u times u prime. So that u part would be my y, so that's the prime. Alright, so now I need to take the derivative of this guy. So the derivative of x plus y, so 2x plus 1. So the derivative of this guy is 1 plus y prime is equal to y plus xy, just like that. So now I need to kind of simplify this brackets here. So what I can do, I have two options. I can divide both sides by this 2x plus y. I can distribute. I'm going to divide this side by 2x plus y. Just like that. So I have 1 plus y prime. Actually, I totally regret that decision. I'm not going to do that. So I'll tell you the reason why I'm not going to do it. It's because I have this y prime locked in up here. I need to get rid of that. So let me instead do that. My second option was to distribute. So I'm going to take the second option. So by distribute, I mean FOIL this out. So let me just do that in a couple steps. So 2. So I'm going to have x first, outside, inside. So first, outside, so x, y prime, inside, plus y, and then y times y prime is equal to y plus x, y prime. So now that I have that, I'm going to distribute through with my 2. So 2x plus, and then sometimes, guys, that's what'll happen, right? This is the process of doing math, is that you sort of take, okay, this is probably the best technique. This should be a plus in here between, guys, just by the way. This is probably the best technique, but sometimes it doesn't always work out, and you realize that partway through, and then you just start over. So that's one of the things that is really important as a student that you need to learn to do. So next step is y primes all on the left side. So the only one I have to bring over is this one, and then everything else on the other side. So both of this guy and this guy is going over. So I'm going to be left with 2x y prime plus 2y times y prime minus x y prime is equal to y minus 2x minus 2y. Then I take a y prime out. I'm left with 2x plus 2y minus x is equal to y minus 2x minus 2y. Just like that. Then I divide both sides by this guy, so I end up with y minus, running out of space here, y minus 2y minus 2x, sorry, minus 2y, all over 2x plus 2y minus x. And there it is. There's my derivative. So sort of made a mess of this one, guys. So I still hope you get the idea behind it, like how to take a derivative using implicit differentiation. Let's try another one and see if I can't get this one correct. So here's another one. This one's a little bit tougher. So, what I'm going to do is I'm going to again take the derivative of both sides. Just like that. So I take the derivative of this guy, so the derivative of xy, root xy. So this is chain rule, so basically u to the 1/2, so it'll be 1/2 u, which is xy. That becomes 1/2 subtract 1, so -1/2, that's the power rule, times the derivative of this guy. So the derivative of x times y is going to be product rule. So it's derivative of x, which is 1, I won't write it, times y, plus the derivative of y is y prime, so xy prime. And then the derivative of this guy, that's product rule again, so the derivative of x is 2x times y, plus the derivative of y, so x squared y prime. Derivative of 7 is nothing. So you can see this guy is pretty hairy already. So now, what I need to concentrate on is trying to get my y primes all on one side, all easily accessible. So the problem is this guy right here. That's the issue that I have here. So I'm going to rewrite this guy. I don't like having that negative exponent there. So what I'll do is I will rewrite that guy, and I don't know again if that's the best option right now, but I'll do it anyway and see what happens. So I'm going to rewrite this first of all. So 1/2 root xy, just like that. So I changed my negative exponent to that, and then I'm going to distribute through with it. So I'm going to take it and go to the y, so I have times y plus 1/2 root xy times xy prime is equal to 2xy plus x squared y prime. So now the only thing I have to do is get this guy to the other side because it doesn't have a y prime in it. This guy to the other side because it doesn't have a y prime in it. So let's see, I'm left with 1/2 root xy times xy prime minus x squared y prime is equal to 2xy minus 1/2 root xy times y. So now I factor y prime out of this guy, so y prime, and then what I'm left with is 1/2 root xy all over x, I'll write the x on top this time, minus x squared, all divided by, or sorry, equal to 2xy minus y over 2xy. Just like that. And I never showed you that. I apologize. Alright, so next step. Divide both sides by this. So this is going to be a little messy. So I'm not going to rewrite that step as much as I probably would. 2 all over x over 2xy minus x squared. So again, this is the derivative, and that's a 2, guys, that's a 2xy. This is the derivative. Now, your professor might not like you leaving this stuff with all this here stuff here next to it, or the root on the bottom. So I'm going to multiply this guy, the top and bottom, by 2xy, just like that. So then I get left with 2xy times 2 root xy minus y, so that cancels with this essentially, all over, let me see, that will be x, because this cancels, minus 2x squared root xy. So now the next step is to try and simplify that even more. So if I bring these inside, they become squared, so I can rewrite this as 4. Well, I guess I don't really have to. I think this is probably good enough. 4xy root xy, because that would be sort of simplest to me. All over y, and then x minus 2x squared root xy. You know, I think that would that will suffice the need. So you see, guys, how complicated these can get, and the algebra behind them is actually harder than the actual calculus of taking the derivatives. So I hope this helps. I made a little bit of a mess of this video, but hopefully it helps somebody. Thanks for watching, guys. See you guys in class.